Graphing linear inequalities is very similar to graphing linear equalities. The only extra things that need to be done is knowing whether to use a dashed or a solid line for the inequality and knowing where to shade on the graph. So here are the steps to graphing a linear inequality. First, change the inequality to an equality for the moment and then graph it like normal. Use whichever graphing method you do prefer. If the original inequality contains a less than or a greater than sign, you're going to make your line dashed. If it's less than or equal to or greater than or equal to, you're going to make your line solid. Choose a test point, some ordered pair that does not fall on the line that was drawn. Then plug your x and y values into the original inequality. Once you do that, you're going to get two results. If the result that you get is true, then you shade the side that contains the test point because that is the true side. If the point you put in is false, then shade the other side, or the side that does not contain the test point. You only want to shade the side that is true. So for the first one, we have 2x plus y is less than 3. So I'm going to turn this into an equality. So 2x plus y equals 3. And I like to use y equals mx plus b. So I'm going to solve for y here by subtracting the 2x over, so y equals negative 2x plus 3, which gives me my slope of negative 2 and my y-intercept of positive 3. So y-intercept is 3, so I'll put my line or my point here, and then I'm going to go down 2 and over 1 for my other point. And I can see that this is a not equal to up here, so that means my line is going to be dashed. So put a dashed line in. Something looking like that. And now I'm going to pick a test point. Anywhere that's not on this line. You can choose whatever you want, but I'd rather choose something simple and easy. I want to choose 0, 0. So my test point is going to be 0, 0. So I'm going to plug this into my original inequality back at the beginning. So 2 times 0 plus 0 is less than 3. So 0 is less than 3. So is 0 less than 3? The answer is yes. So this is a true statement. And since it's true, I look for where my point is, which is on this side of the line. And so I'm going to shade everywhere on this side, or at least enough to emphasize that's the side that's true. And that's all you have to do to graph a linear inequality. So let's do another one. 4x minus 2y is greater than or equal to 6. I'm going to turn that to an equality. So 4x minus 2y is equal to 6. I'm going to solve for y, so I'm going to subtract the 4x over. So negative 2y equals negative 4x plus 6. Then I'm going to divide everything by negative 2. So y equals 2x minus 3. So my slope here is a positive 2, and my y-intercept is a negative 3. So negative 3 on the y is down here, and my slope of 2 means I'm going to go up 2 and over 1. And since my original inequality sign is greater than or equal to, it has the line underneath it, my line is going to be a solid line going through the 2 points, or going through near enough. And now I'm going to pick a test point anywhere on the graph that's not this line. So pick again something simple. I like 0, 0. So my test point again is 0, 0. And I'm going to plug it back into the original inequality. So 4 times 0 minus 2 times 0 is greater than or equal to 6. So 0 is greater than or equal to 6. So is this true? Is 0 greater than or equal to 6? No, this is false. So my test point is on this side of the solid line. So that means that since this is false, all over here are false, which means everything on this side is true. So this is the shaded side. And that's it. Last, 2y is greater than 5x. So 2y equals 5x. Solve for y by dividing by 2. Y equals 5/2 x. So I get a slope of 5/2 and a y-intercept of 0, because this is essentially plus 0. So going through 0 right here at the origin, and then my slope is 5/2, so I'm going to go up 5 and then over 2. And now this is not equal to, it's just greater than, so my line is going to be a dashed line. And I will pick a test point, but I can't use 0, 0 this time because it's going through 0, 0, so I'm going to choose this one here, 1, 0. So this time my test point is going to be 1, 0. So now I'm going to plug that back into the original. So 2 times, and the y value here is 0, is greater than 5 times 1, which is the x value here. So 0 is greater than 5. So is 0 greater than 5? The answer is no, that is false. So since the false test point is over here on this side of the line, we're going to shade everything on the other side, everything over here. And that is graphing linear inequalities.